have a chance to fail without it really costing you very much, except for your mind, I guess. At the same time, I have no trouble asking questions of you on the homework that are of a different level of difficulty than the test. I would say that this is beyond the level of difficulty of the test. Not terribly so. Maybe 2 sleds would be okay. But 3 sleds makes it a bit on the redundant side. Now, we are told that the incline has an angle of theta and that there's a tension applied to the first sled. And our first question is find the acceleration in terms of m1, m2, m3, theta, and g. Now, there's no friction acting in this question. So, although this is going to sound like a shortcut, it really isn't. How is this different from the standpoint of the applied force? What if I just stacked all the sleds on top of each other? Wouldn't I have to pull just as hard to get it up the hill?
Yes.
So I guess we'll go from here. Meaning net force equals MA. Let's go ahead and kind of figure out where my forces are. I've got a downward force of weight, upward force of normal, and the tension. We've done this a lot, haven't we? So can I be forgiven if I just say the force down the ramp is going to be M1, M2, well, they're all summed. M1 plus M2 plus M3 G, I can't even write it. I'm out of space. So I'll do better. M1 plus M2 plus M3 times G sine theta. Is that okay? If not, ask. Okay, so do you have a question or you just want me to explain that more deeply? All right. Luckily, they're right here. That makes it the hardest two to figure out. Because if we look at sled 1, it's experiencing tension. It's experiencing its own weight backwards, M1G sine theta. And it's experiencing tension between 1 and 2 backwards. Do you guys see that? Please ask. If not, I'm skipping steps. All right. Well, if we all see that, if I'm going to make that the x direction, net force in the x direction is going to be equal to M1A, which means tension minus M1G sine theta minus T12 equals M1A. And we want to solve for this. So T12 equals T minus M1G sine theta minus M1A. That's a mess. Such a mess, isn't it? You know what the real mess is? Back there, look at all that garbage. Holy smoke. Figure out what this tension is. Well, all bets are off now. You got to work it out. That's going to be harder. Now, to do that, you'll have to look at just box 1. Box 1 has the same tension acting on it, T. It has M1G sine theta acting on it, and it has the tension between 1 and 2 acting on it. All right, it's solved. I'm going to explain it by carefully drawing this out for what I hope will kind of be, I don't know. Oops. Why is this not working? There we go. This is the weight. And it's the weight of all 3 of them. I'm grouping them together as one object. So M1 plus M2 plus M3. Then I've got this normal force. And I don't know what that is. So I'm just going to write normal force. But then I've got this pulling force. And that's tension. This weight is actually all of that times g. Now I need to break this up into a coordinate system. So I'm going to choose a coordinate system that is aligned with the normal force and the tension. So you all who have questions with this, get them answered now. This is theta. Any question about that? Knowing that that's theta, I'm going to draw a triangle. That is a right triangle aligned with my coordinate system. Now, this is the adjacent side. This is the opposite side. Opposite goes with sine. Adjacent goes with cosine. So this side has to be m1 plus m2 plus m3 all times g times the cosine of theta. All of this is just the length of that vector. So it's mg, but I have to put all three of the masses together. For the opposite side, I'll have m1 plus m2 plus m3 all times g times the sine of theta. It's the opposite side, it goes with sine. So this arrow is this, I can place that arrow right here. It represents the same thing, just moving it from here to here to put it on the axis. And labeling it m1 plus m2 plus m3 all times g sine theta. Now, I could get rid of this red one, but I think this will let me erase that part, so whoop. Bye. There we go. Get rid of all this extra stuff so I can kind of focus on what's at hand. Those are my four forces now. Two of them are components of the weight, but they're all lined up perfectly in the x direction and the y direction. Is that okay so far? I mean, if you want, we can adjust them. Trying. Terribly, apparently. This program isn't great, but it's the only one that does this. There. Kind of. Maybe not. Look, I'm just wasting time right now, apparently. Just be my friend. That's it. That's all I'm doing. There it is. So, getting back to the task at hand, net force in the x direction, which is this direction, is going to be equal to MA, but M is all three of those boxes. There are two forces in the x direction. Tension minus M1 plus M2 plus M3. I just should call these like capital M. It would be much easier. And now I have to solve this for A. And you had to find some way to type this into mastering. Poor kids. I'd feel bad, but I don't. Ta-da! All right, so go on, because that's just question A. There's part like B and... Actually, this is question B. What was question A? What will happen to all the sleds? They'll accelerate up the ramp. Okay, that was easy. B is this one. C, determine the magnitude of the tension in the rope that connects sled 1 and sled 2. Express my answer in terms of all of those variables. Great. Great. Here's the deal. This is the acceleration of every one of the sleds, right? Every sled accelerates that amount. We got it? Any question about that? So I want the tension between sled 1 and sled 2. Substitute that in for A. And simplify. Are you ready, kids? Take a look. For you to fear, again, we're just kind of treating this as if it's one big sled. I'm just going to deal with this big M for a minute, okay? Net force on the system is going to equal, they tell us it's moving up there. They don't even tell us. We're trying to figure out the acceleration. So it equals MA. I'm going to skip a step here. It's tension minus mg sine theta equals MA. Right? Where M is all the masses of the sleds. I could break this up into components, but I quite literally just did that 5 minutes ago. So the acceleration will be T minus big M g sine theta divided by big M. So to get that all kind of written out, that's T minus...
Teachers and students, pardon this interruption for one afternoon announcement. Boys soccer conditioning is canceled for today. Again, boys soccer conditioning is canceled.
Oh, they can't run in the rain.
Thank you very much.
There you go. Now, that's the answer to question B. Unfortunately, the next question asks, alrighty, T12 equals, all right, T minus M1G sine theta minus M1, all right, A, T minus M1 plus M2 plus M3 times G sine theta all over M1 plus M2 plus M3. Yeah, you're not whistling Dixie, are you? How many of you are scared by just looking at that? I'm with you. Now, do you realize you can get common denominators? You can. You can get common denominators. And believe it or not, when you get common denominators and start working this out, a ton of stuff is going to cancel. But you have to get there first. Now look, I'm going to hit pause here. It's not pleasant. Oh, you're a hard pass. Break this problem up into the x direction and the y direction. And I'm just going to line it right up with the one force. So this is my positive y direction, this is my negative y direction, and this is my positive x direction, and this is my negative x direction. So to do this problem adequately, I would need to break up each force into its components. That would be the first one. And to break it into components, this is going to be 4 sine 25. And this one, it's going to be tough to write it all in here. I didn't give myself a whole lot of space. 4 cosine 25. Any question about that? All right. You guys are in pre-calc, right? Excellent. So you understand that if I give my measurements relative to positive x, then I can just feed those right into the calculator. And this is going to be 6 cosine 325. And this is going to be 6 sine 325. And the calculator will spit out positive and negative, and I don't even have to do any thinking. Right? Pre-calc will teach you that if it hasn't already. It's the unit circle. Lovely. Now, if you don't know that, then you probably needed to find this angle, which was what, 35 degrees? And then interpret that this is in the positive direction and this one's in the negative direction. That's how I would have taught you to do it. And that's what I did teach you to do. So at this moment, I have net force in the x direction is going to be 6 cosine 35 plus 4 cosine 25 minus 8. And I don't know what this equals, but I think somebody yesterday got 0.5 when I was working with them. And the net force in the y direction is going to be 4 sine 25 minus 6 sine 35. And somebody yesterday got negative 1.7. All right, any questions about those two? All right, that's not the answer. They want the magnitude and direction of the answer. So to get the answer, positive y, positive x. I'm going to go out 0.5 in the x direction for my x force and 1.7 in the negative y direction for my net force in the y direction. And that's a right angle, even though it doesn't look like it. And that means that this is my resulting force. Take my answer and go back and put it into vector form. Pythagorean theorem will do that, right? And then inverse tangent will give me the angle. I don't know whether you're allowed to express it as a negative degree or whether you have to express it all the way from there. Probably knowing mastering, you have to go all the way around the hub. So subtract it from 360. So I don't remember who asked, but is that enough? All right. All right, so I've got my box, it's on the ramp, it's experiencing 4 forces: tension, normal, friction, and weight. I've drawn a coordinate system aligned with my inclined plane. I've taken the one off-axis force, the weight, and broken it up into 2 components. That summarizes what we've done. I'm saying all of those things because I wasn't recording earlier, but I also want to kind of just draw this to the side. Normal and mg cosine theta. Those are just the y forces. Everybody okay with that? I'm drawing them apart. And over here, tension, mg sine theta, and friction. Those are just the x forces. Kind of separating them out, because I'm going to separate out how I solve for them too. I'm going to say net force in the y direction is 0. It doesn't sink into the ramp. It doesn't fly above the ramp. So normal minus mg cosine theta equals 0. Normal equals mg cosine theta. All right. Still nothing. Other side. Net force in the x direction equals 0. I know it's 0 because it says in the problem, constant velocity. I'm pulling up the box at a constant speed. So, tension minus friction minus mg sine theta equals 0. Now, it's at this moment that I probably should see what the question is. My steps gets me here. But that doesn't answer the question. So now I'm going to see what the question is. What force do I need to exert on a rope? Okay, they want the tension. That's what they want. I will only be able to give them the tension if I solve for T. So T equals mg sine theta plus friction. I can solve this if I have mg, theta, and friction. I have 3 of those things. I have mg and theta. I don't have friction. Is there a way for me to get friction? There is. Because I know friction is equal to mu times the normal force. Friction is a percentage of the normal force. What percentage? 30%. They gave it to me in the problem. And I have the normal force sitting right here, suggesting that friction equals mu mg cosine theta. Do you know how this must be the way every single ramp problem with friction is? Look, the normal force is always going to be related to cosine. Friction is always related to the normal force. Friction's probably always going to have cosine theta in it on a ramp. Do you see why that's got to be true? It's very likely. Now at this point, I got to get all the numbers and plug the numbers in. That is the least interesting thing. mg sine theta plus mu mg cosine theta. There's my answer. Now, yeah, you can put the numbers in. How many of you really want to see the number part? All right, so what is m? 12 times 9.8, because this is mastering, times the sine of 30, plus 0.3 times 12 times 9.8, because this is mastering, times the cosine of 30. Keep going? Or can we be done? I'm done now. You plug and play. Be aware, though. Pluses, minuses, don't be complacent. The friction was down the ramp because the box was being pulled up the ramp. Right? If the box was sliding down the ramp, the friction would be up the ramp. Don't be complacent. The rope could break halfway up the ramp, and then I would ask, what's the acceleration of the box down the ramp? You would have to know that friction changed directions because now the box is going down the ramp. Little things like that. Just be aware of. Be prepared to deal with direction of friction as something you should think about. Yes, ma'am. This for anybody who's not going to listen tonight on this. What if they don't give you a coefficient? Do you just assume there's no friction? That's a situational answer. And I'll explain why. What if I told you that the box was at rest on the ramp? Is there friction? There has to be. The box can't be at rest on the ramp unless something else is causing it to stay put. So in that circumstance, you need to interpret. So I don't want to say unilaterally that if there's no coefficient of friction, that it means there's no friction. I will tell you on your next test, if you're unsure whether there's friction or not, then ask me. I will try to make sure it's clear. But if you hear the words, I can't tell you that, then I'm trying to get you to get it from the context of the problem. There's something in the problem that's telling you. Okay? And on your first test on this material, which is going to be what day? I will very likely not try and screw with you there. I will say in the problem whether there's friction or not. I believe this stuff is hard enough without the having to figure some of those things out. So I'm just going to ignore the normal force because there's no frictional force. And I'm going to notice that down the ramp has got to be mg sine theta. And up the ramp's got to be tension. I don't really know what direction the system goes, by the way. I don't know whether the weight's enough to pull the box down or for it to be pulled up. I'm going to decide to make this direction positive, but I'm guessing. Does everybody understand? I'm guessing. Now, on that block alone, that means that mg, which is 28 times 10 times the sine of 37 minus t equals ma. Any question about what I wrote there? If I've chosen this way to be positive, then this way is positive as well, right? The box can't go down the ramp if the other box doesn't go up into the air. Are we all okay there? Make sure before I go on. All right, two forces on a 12 kilogram box. T goes up, weight is down, times 12A. Any questions? Okay, I can move on. All right, so what's 28 times 10 times the sine of 37? I don't know the answer. I'm just a school teacher, barely doing that.
You don't even have to put the 28 in, you can just cancel it.
No, I can't.
28?
I can't.
Cancel?
I can't, because there's a t right here. Shh. I can only do it if I can factor it out of the t. Look, everybody makes this mistake. Shh. I've watched like 6 of you do it. But you can't factor the 28 out. I know there's one right here and one right here, but I have to be able to factor out of every term on each side of a relationship. And since it's not there at the t, I can't factor it out. But I've watched so many of you, at least half of you do this at least once this year. But you can't. That's why I can't take the 12 out of these. Same reason. All right. Who's got 28 times 10 times 37? Or sine 37? What is it?
165.
What?
165.
What is it?
Negative 180.
So 160 what?
168.51.
It's weird that there's 4 different answers for this. Of course, if your calculator's in radians, it might make it harder. Okay, I don't want 9.8. All right, minus t equals 28a. So I'm good right now. I can stay with this. And this is t minus 120 equals 12a. That okay? Am I all right, guys? Is that yes? 12 times 10? We good? So I'm just going to add these two equations to get 168.5 minus 120 equals 28a plus 12a. That looks like 48.5 equals 40a. Am I done? Just solve for a? Well, guys, go home. Avoid the raindrops. See you. So for this part of the quiz, we had, let's see, this one was 15 and this one's 5. Everything was frictionless. So your job is try and figure out what the acceleration of the system was and the tension. Now, follow your steps. They'll get you to the answer. So when I'm looking at this one, I'm thinking there's weight down, normal up, and a tension to the side. Wouldn't you agree? Now, I'm going to make to the right positive. That seems to make the most sense to me, so positive. And I'm not going to even worry about the y direction because nothing's happening there. But in the x direction, net force equals MA. So tension equals 15A. It's as far as I can get. Now, is there any doubt in anybody's mind that if the 15 kilogram box moves to the right, the 5 kilogram box has to move down? Now, you have a choice here on how to deal with that, but I'm going to make everything that's going downwards here positive. For one simple reason. The acceleration of the 15 kilogram box has to be the same as the acceleration for the 5 kilogram box. Is there anybody in this room who wants to question that? Have courage, raise your hand, and bring it up. Otherwise, you're telling me you all understand it implicitly. Okay?
So is it positive? Like, it's technically for that 15 to go, it's positive, so then it's like the same thing, so it would just be positive as well.
Well, here's the things that I've said to you guys in your set of steps. The first one is that choosing direction is arbitrary. You get to make the call. But I also said, and this doesn't always make it into everybody's notes, they have to be consistent. Well, to be consistent here suggests that what I call positive for one weight should also be positive for the other. I'm saying that the 15 kilogram is accelerating to the right. I don't think there's any reason to disbelieve that. But if the 15 accelerates to the right, the 5 has to go down, right? It has to accelerate downwards. So if I'm saying that this way is positive, then by necessity, that way has to be positive too. Now, this is not how your textbook does it. Who read about it in the textbook? No, then I guess it doesn't matter, does it? So I'm not going to worry about all of you people who read it in the textbooks. That's none of you. I will say this. All right, so getting back to this problem, I'm going to look at the bottom box, and I was looking for this picture specifically. I was looking for you to show me that the tension was less than the weight here. I want to see that on your picture. It can't accelerate downwards if the weight upwards is, if the tension upwards is greater than the weight. Look at your answers. Do you know how many of you have a tension of 75 newtons? It's more than half. The box weighs 50 newtons. How can it accelerate downwards if the upward force is greater than the weight of the box? Do you understand where I'm going now, right? So for all of you who have 75 newtons as your answer, question yourself just a little bit more. This box weighs 50 newtons. The tension on it's going to have to be less than 50 if it's going to accelerate downwards. Otherwise, you're saying that the box floats upwards. That's what you're saying. Also, for all of you who said the acceleration was the acceleration of gravity. Really? You did the lab. Did the thing that fell on the side of the table fall at the acceleration of gravity as if it were dropped? It didn't. So you've seen it, but you just get bogged down in the details. So here we go. I'm saying downwards is positive. So 50 minus tension equals 5A. There are a bunch of you who have T minus 50 equals 5A. You made upwards positive. You can do that. That's fine. But if you decide to make upwards positive, you still have to be able to interpret that the acceleration was negative. So you have to put a negative sign here for the acceleration so that it matches what you said was happening to the other block. You said the other block was moving to the right. I said you had to be consistent. That's all I said. I would, if I were you, pick a single direction to call positive and label anything in that direction positive and make that the direction of any acceleration in your system. You will be happier. And I hope you're writing these notes down. For tomorrow will be the last time you can do this with notes in hand. Now, this is not the end of the problem, but I want to bring these two things together. To get the answer, I now have to do a little math. And the math that I'm going to do is just to add these things together. The negative t and positive t cancel, giving me 50 equals 5 plus 15a. I'm writing it this way because I want to talk to the smart people in the room, which is a whole bunch of you actually at this point. What causes the system to accelerate? Anybody besides Kyle? Really? You're gonna let Kyle speak for you guys? That's okay, but he gets his hand up there first, and I want to hear from the whole class. I'm more than welcome to hear from Kyle. He'll probably give me the right answer. But I'm trying to distribute this. Emma, what do you got? Gravity causes the system to accelerate. Which box does gravity act upon? And, I'm sorry, let me say that different. Which box is the force of gravity effectively causing the system to move? It's the 5. So this 50 Newton force here is the unbalanced force on the system. That is the unbalanced force, which has to equal the inertia of the system times the acceleration. You do see that we're getting the inertia of the entire system here. This will show itself in almost every problem. Where you have more than one object moving, the inertia of the system has to show up. So I'm always looking to see, do you have the inertia of the system somewhere? Anyways, long story short, you find that the acceleration is 2.5 meters per second squared. To find the tension, you plug that back in for A here. So T equals 15 times 2.5, which is 37.5 newtons, which is less than 50. And we're done. I'm going to move on to the next one. If you have quiz B, this is what you started with. A lot of you made little mistakes here. So let's handle all the pieces. Every inclined plane problem is about the same. And you guys who didn't have this one, you really should walk through this one. You should draw that free body diagram that has a force downwards, a tension upwards, a normal force perpendicular to the ramp, a frictional force down the ramp. These are all the forces acting in the system. Any question about them? Step 1, draw a free body diagram. Step 2, make a decision about your coordinate system. That's the coordinate system I'm going to use. I'm going to choose this way to be positive and this way to be positive. I'm going to take any off-axis force and break it up into components. I'm going to recognize that the angle here is the angle here. And we've done this once or twice already. So I feel confident in skipping around and saying that this is mg cosine 30 and this is mg sine 30. I'm going to pause right here. Is there anybody who needs a piece of this reviewed? Then I'm going to change the way I've drawn this so that I can exaggerate a couple things. All right, so now I've just got the forces written as they appear in the x direction and the y direction, so I can focus. In the x direction, there are 3 forces. They must equal ma, because I was told the system is accelerating 2 meters per second squared. The 3 forces are tension, that's up the ramp, mg sine 30 down the ramp. That is the weight of the box down the ramp. Friction. Friction is down the ramp because the box is sliding up the ramp. Be careful about that. Earlier we had the box sliding down the ramp, and so friction was up the ramp. Friction opposes motion. So because the box is going up the ramp, the friction had to be down the ramp, and that's why I'm making it negative here. And that has to equal ma. Now I could put in all my numbers, T minus 5 times 10 sine 30 minus friction equals 5 times 2, but I can't solve it because I don't know friction. But I remember in a prior of Mr. Shelton's lectures that friction is related to the normal force. Perhaps because he gave me mu, I could figure out what friction is. To do so, I would have to figure out the normal force. So net force in the y direction must be equal to 0. There are two forces in the y direction, normal and mg cosine 30. Look, it will always be this way for a ramp. Always. You can memorize this. So far, you've been able to use your notes and look it up. Tomorrow, that ends. So you might want to commit it to memory. Make a couple study cards. Learn them. It will not be on the board. Of course, you can always do trig. This is going to be 5 times 10 times 0.866. I'm saying that because I'm going to bring it up here and say that this is 0.3 times 5 times 10 times 0.866. I don't know what that is. Could somebody please tell me what 0.3 times 5 times 10 times 0.866 is?
43.3.
What is it?
43.3.
43.3?
Well, that's 12.9.
I think it's 12.92.
Oh, I forgot the point.
Okay. So 12.9? Okay. And then that means T minus 25 minus 12.9 equals 10. Good? 25 and 12.9 is what? 37.9? Add it to both sides, and I get 47.9 newtons. Look, a few of you made, it's like 4 of you in the room made one of these positive somehow. That's pretty minor. Okay, there's a lot of stuff written here. You can make that mistake. It's going to happen.